Great. Thanks, Ingrid. All right. So asphalt pavements are versatile. No other engineering product provides such versatility. It's used for residential driveways, heavy duty interstate highways, airport runways, railroad underlayments, commercial, industrial, and recreational facilities. Today, we're going to talk about recreational facilities and different uses. And really, we're not talking about roads today. So in order to ensure good performance, it's important that we select the right mix. We have to use the right mix in the right place. Um, a high volume road mix will not perform well in a sports application. So roads are not equal to sports. Here's our presentation outline for today. We're going to spend some time talking about sport courts, and then we'll talk a little bit about trails and paths. Next, we'll move on to porous asphalt and then other special mixes that are available. With the popularity of sport court installations continuing to rise, there's a desire to provide guidance that would be of benefit to the owners, producers, and customers alike. The American Sports Builders Association is a nonprofit trade association comprised of builders, designers, and suppliers for sports facilities. It exists to promote the highest standards of design, construction, and maintenance. They have many publications and is a great resource. The website listed on here is sportsbuilders.org. So when we're talking about sport courts, there are a lot of things to consider. Surface tolerance and macro texture are critical. Heavy vehicle loading is not really the design criteria that we're using here. Like I said, we're not designing sport courts the way we do with roads. Resistance to cracking is the primary consideration. Materials mix design must consider these differences. We also have to think about orientation relative to the sun. So when we're evaluating where we're going to lay out an athletic sport court design, it should be laid out to minimize players looking into the sun when serving or following the flight of the ball. The court should also be laid out to avoid distracting shadow lines or patterns on the court surface. So you have to really kind of think about orientation when you're laying out your sport courts. Some other design considerations, what other structures and features are on the site? What are the prevailing winds that may, help with orientation as well? Property lines, zoning requirements, topography of the site, typically with a sport court, you're going to want to put it on a very level area. That'll play into where you're going to lay that out. Trees and existing vegetation, very important here. Anytime you've got a sport court, you don't really want trees near it because tree roots can damage the pavement. Also, if you have a lot of shadows and things like that, then moisture can sit on the pavement. It might not dry off as quickly and things like that. So these are all things that you need to consider as well. So what does a sport court comprised of? Basically, starting from the bottom up, you've got your existing subgrade soil. Typically, you're placing an aggregate base over that, and then you have the asphalt layers above that. Typically, one or two layers of asphalt, and then you typically on sport courts we're putting on a coating, which is the playing surface. So when we talk about the different layers with the subgrade, that's your barrier between the ground and the court. It's very important to understand what type of soils you have in the subgrade. The subgrade's there to, provide a flat base. You want a subgrade that's, blocking roots and organic matter. Also, you want to make sure that, you're not getting any trees there. If there are existing ones, you want to make sure that you're taking out all the tree roots and stumps and things like that so that you don't have any growth underneath there. With the aggregate base course, here we're putting that over the subgrade, and we want to put that there to prevent any frost damage and also give any water that gets into the pavement structure a place to be drained out. Or if there's water coming up from the subgrade, you want to get that water out from underneath the surface. With the asphalt layers, you want a stable and flat surface for the playing layer. So typically when we're putting sport courts, they're pretty flat. We're not grading them so that water drains off them super fast or anything like that. So we want to make sure that we've got a nice stable flat surface, and that we can put that wearing layer on. So that surface layer or that coating. With different courts or different sports facilities, there are different types of wearing or playing layers. And that's, the surface that we see. It's typically colored and lined and different things like that. And there are different options. The coatings that we put on a track are different than the coatings we put on a tennis court, or different types of athletic facilities have different needs there for the playing surface. When we talk about the asphalt design, it's important that we're using high quality aggregates. We don't want any deleterious materials, any wood or vegetation, shale, pyrite, clay balls, any friable particles. We don't want any slags. Slags contain metals and are highly absorptive. The coatings won't stick to them. If they get wet, they can cause rust stains and things like that. High natural sand contents may be more sensitive to moisture susceptibility. Typically, you want to, limit the natural sands to under 20% in your mix designs. And really, many producers, I know from here in Michigan anyway, a lot of times when they're doing a sports court and that, they have a special mix design that they use where they use 100% limestone mix design for that. And that makes sure that they don't have those deleterious materials in anything that you get sometimes if you use the natural aggregates, like gravels and different things like that. When we're talking about asphalt design, it's recommended that, you can use some wrap in it, although, you don't want to use a whole lot because you got to be careful about those deleterious materials and slag being in your wrap. Typically, it's processed over a half-inch screen, so you want the smaller particles of wrap, typically limited to 10 to 15%. A lot of people will specify no wrap in the top course. So if you're doing a two-course thing, maybe there's some wrap in the base course, but not in the top course. And that's to make sure that we're not getting any of that deleterious or staining things that can happen on the surface. Other materials, when we're talking about sports courts, recycled shingles, no, it's not recommended to use those. That can really stiffen up that binder. And when we're designing sport courts, we're not designing them for loads or, where we might have repeated loads and, we don't worry about rutting and stuff. We worry about cracking. So we want to use a very durable mix, and asphalt shingles usually make a stiffer mix. Not necessary to use polymer modified binders. Not really necessary to use ground tire rubber or fibers. More mix additives could be used as needed, and anti-strip additives as needed. Typically, we don't use those here. If we're talking about our sport courts here in Michigan with our limestone mixes, but in other states, sometimes they have to use anti-strip additives to meet the TSR requirements in their mix designs.
So we got a question in the chat. So no wrap, all limestone aggregates for a sport court asphalt. Is that
for the top course? Yeah. If you're doing two courses, like if you're typically placing about 3 inches thick over 6 inches of ag base or something like that. If you're doing, your leveling course, you could allow some wrap in that, but typically, most of our producers here in Michigan have that special mix design that's 100% limestone, no wrap for the top course.
Awesome.
Yep. Good question. Okay, so now we move on to construction, and since water is the most common cause of any of the surface failures that we see in sports court, it's adequate drainage is really the most important consideration in selecting our sites. So selecting proper drainage system to move water away from the site, that includes, any subsurface drainage. Depending on your subgrade in that, you might have to put some drains in to make sure that it can drain any water so you don't have water wicking up from underneath. And then surface drainage systems, like I said, we're typically sport courts are pretty flat. So we want to make sure that we're collecting that water as quickly as possible and getting it out, maybe using precast channel drains. Picture one of those showed alongside this track here. Open pan drains, swales, catch basins is it's just very important that we're draining the site properly. Since we are sealing up that asphalt layer with a coating on it, any moisture that gets trapped into the pavement section can just cause issues. When we're talking about the subgrade and base construction, as with any asphalt pavement, we need to take into account the subgrade and the base. We want to make sure that they're properly prepared and that they're properly compacted. It's important that we have a nice stable foundation underneath our asphalt, because as we're placing the asphalt, we're not concerned as much about traffic and stuff. So we want to make sure that asphalt's durable. And the way to get asphalt to be durable is to have a good quality mix that is properly compacted. And that starts with the base underneath. Some tips for when we're constructing the asphalt. Obviously, if we're placing it in layers, proper tack application is always important so that those layers act as one. You might want to offset joints in between the layers so that you don't have a plane of weakness all in one spot. You want to allow positive drainage towards any drainage outlets. You want to make sure that we're minimizing any segregation, no broadcasting material. So, you want to minimize handwork. So it's best to lay out these things so that you can just place it all with the paver. Getting density is, like I said, it's very important. You may need to use vibratory or oscillating rollers. Focus on paving those joints and seams between the pulls. You don't want to make sure that we're getting enough material and we're getting density at those joints. You want to look at the layout and how you're going to pave it. You want to make sure you got shorter pulls and schedule your trucks and your mix coming in right. Because we got to make sure that we're getting all the density as we're placing it. We're not getting additional consolidation from traffic like we do with roads. Want to keep the joints hot. 220 degrees is a good target. Pave it all in the same day if possible, so that we're paving it quickly to keep those joints hot and better get density at those joints. Then when we are paving the pulls, we want to make sure that we're overlapping the mat. And again, that's just kind of best practices on making sure that we're getting density of those joints. Typically, we're going to target a little higher density on a court application. 94% is a good rule of thumb, because again, we're not getting that extra consolidation from traffic. And then we want to make sure when we are rolling it that we're not getting any check cracking from over rolling or rolling when the mat gets too cool and things like that, because that can just create a lot of tiny little cracks that can let moisture into the surface.
We got a question about fencing and posts while we're talking about, these sport courts and other non-standard pavings. Is it better to core and place after paving, or cap the net posts and pave over them when you're doing something like a pickleball or a tennis court, etc.?
Yeah. And typically with those, I think there might be a mention on one of the slides here coming up, but typically you want to place those prior to paving. So that goes into some of the planning as you're paving, because a lot of times those posts require having a concrete foundation to hold them in place. well enough. So you're going to want to put those probably while you're, preparing the subgrade in that, because they need to be deep enough for frost heave, especially here in Michigan. So those are probably going to go in during that subgrade preparation. Then you're going to be placed your ag base, and then paving. So you want to kind of plan your paving around where all those posts are as well, so that you can, plan out, have continuous pulls and get back there and minimize your handwork. Kind of some of the things I was talking about there.
We've got a follow-up to that. How can you ensure asphalt slope requirements when paving after the posts have been installed?
Asphalt.
The slope requirements. So how can you make sure that your pavement is sloped correctly after you've put those posts in? Is that a challenge to try and
That is, and yeah, my next few slides are talking about the leveling and slopes and control and all that kind of stuff, because it's very important with the courts here, because typically, we're designing these things with like 1% slope on them, where, kind of best practices for parking lots and roads and things is at least 2% minimum slope. So
less room for error here?
Yes, there's a lot less room for error here, because we don't want to make any ponding areas or anything like that, because water is the enemy.
All right, sounds good.
Yeah, it takes a lot of care and planning, and as well as design. So everything has to kind of work together. It's not like I'm just going to pave a square and then go out and pop some posts in and all that. Because if you don't properly put those posts in, they're probably going to be moving around on you and things anyway. So good questions. Some more tips for paving the asphalt, smoothness deviation, because those slopes and grades are so important, no greater than a 1/4 inch in 10 feet on the lower layers, and no greater than 1/8 of an inch in 10 feet on the upper layers. So very tight tolerances there when we're paving. So we need a lot of controls, make sure that we're putting things in at the proper elevations. We want to protect the asphalt prior to coating placement. We don't want it getting all dirty and stuff. Typically, you've got to wait about 45 days to put the coating on after the asphalt. You want to give that asphalt time to cure, and that so that the coating can stick properly. So keeping that asphalt surface clean gives you a better chance that coating is going to adhere to it properly. We also need to be sensitive to weather events and time of the year, and plan out, because you've got that 45-day window between paving and coating. We don't want to be out there paving the court in October and then hoping that we can get it coated before winter and all that kind of stuff. And we probably don't want to let it sit all winter either. Then it's just going to collect a lot more dirt and dust and grime. So a lot of that stuff has to be taken into account when we're planning out the project. So courts require a minimum slope of 1 inch in every 10 feet. So like a 1% minimum slope. And like I said, that's less than what we typically see in parking lots and roads. And they have to be on a true plane from side to side and end to end, corner to corner. So it's very important that a lot of slope and grade control is happening when we're laying out these things and when we're paving these things. So a lot of work goes into making sure that they're smooth and everything. You can see on the bottom left picture here, checking that grade and slope. It's nice when you got 2 levels going in, because maybe with your base course, if you find some areas, you can mill those off and make sure that everything's set up properly before you put your top course on. Makes it easier to meet all the grade and slope requirements. So what happens if we don't meet those? We get bird baths and ponding, right? So like I said, it's very important. If we have these areas, once we put the coating on, and water sitting there, it can degrade the coatings as well. Obviously, we wouldn't want to be putting the coatings on while there's still water on the asphalt surface or things like that. So that's going to just make things more difficult. So slopes and grades are important to get that proper drainage. So, one of the big problems is we're paving a big area in most of these courts and things like that. And, we're not gonna see cracking and stuff from traffic. We're gonna see cracking from the asphalt shrinking over time. And where's that asphalt gonna crack? It's gonna crack at its weakest point. So it might be on a paving seam, things like that. So one good way to kind of control that is putting in control joints, sawing and sealing control joints into that surface. And then that can control where those cracks are happening. So, for example, like this picture here with the tennis court, they put a control joint right at the fence post line where the net is, and then in between the courts. And that's a pretty good practice because there's a lot of stresses and strains even from the nets. Those posts have a lot of tension on them and things like that, so that can cause more tension and you can get cracking around there. But if we can control those cracks in between the courts and there, then it's not on the playing surface. So it's a good control measure to control where those cracks are. And
We
by
had a
sawing and
We had a
sealing them,
question
we're
in the
keeping them-
chat here
Oh,
about how are joints kept hot? This was a little while ago that was asked, but is it a concern when you're putting these big swaths of asphalt down that those joints are kept hot? Especially maybe if you're putting new asphalt down next to old?
Yeah, if you're putting it down next to the old, you're going to have a cold joint there. But what I was talking about with trying to keep them hot is planning your paving pulls so that they're pretty quick, and so that by the time you pull back and you're paving the next course next to the one you did previously, that joint is still warm, so that we can get good density there.
I feel like a repeated piece of information with this is planning, regardless of anything
Definitely,
else. Planning.
Yeah, it is good planning. Yes, yes, definitely. Okay, we were talking about the control joints. I think I covered all of that. Yeah. Next, some other types of issues that you can see are staining, stains on the court and stuff. And really that typically comes from any pyrite minerals, clay balls in the aggregates, or metals and slag, different things like that can cause staining. So that's where it's important, to make sure that we're not allowing those materials into the mix designs. And that's why a lot of our producers here in Michigan, they have that 100% limestone aggregate, then they don't have these issues. Another issue that can happen is selecting a mix that has larger aggregates in it, and then not selecting, a thick enough paving course. So paving thickness is important. When we talk about paving thickness, we want to have a minimum thickness of 3 times our nominal max aggregate size in our mix. So, if we're trying to pave like a 13A mix at 1.5 inches, you can start dragging stones and things like that, and that can cause issues in the future after we've coated that, where you get stones popping out and things, and cause some scars there. Another thing that we can see are blisters. And so this is where the coating kind of blisters up after being in place for a while. And how does this happen? It's usually moisture's trapped in the asphalt, either within the asphalt or underneath the asphalt. And then the thermal gradient, it's hotter, on a sunny day and things like that. So that water wants to kind of expand up, and the vapor pressure in there exceeds the tensile strength of that surface of the asphalt and causes that coating to blister up. So that can be an issue. So a lot of these coating systems are multi-layered coating paint systems that seal up the air voids at the surface of the asphalt. So if there's any moisture in the asphalt or underneath the asphalt, it can't really escape. And if we don't have proper drainage in the base or the subgrade, so it can escape out underneath, that can build up that vapor pressure inside and cause that bubbling. So again, proper drainage systems is very important because water can cause a lot of problems. Some other design considerations, like I said, the recommended cure time should be a minimum of 45 days. So that's where that planning comes in. The surface coating application is important, timing, application rates, and properly curing that. Some of those coatings need to properly cure for a certain amount of time. So you got to, plan that out with time of the year, weather, all that kind of stuff as well. So like I said, proper drainage systems are important. And when landscaping and laying out your plans, you got to consider what type of vegetation is being planted and its potential growth and future impacts. If we've got a lot of plantings next to the court, over time they're going to grow up. And if they cause a big shaded area on part of the court, then, that can cause issues with, water or moisture just sitting on the top of that coating surface and can degrade that as well. So most of the coatings are meant for, being out in the sun, being dry and things like that. So all these things, planning is key and drainage and keeping water off is key.
So that goes into we got a question about opinions on winterization, dewinterization of posts on the court. And I would say that, anything that you can do to prevent water from getting in around that post over the winter and freezing and expanding is going to be helpful. Do you have any other comments there?
A lot of the posts, like especially like on a tennis court and stuff like that, kind of what you can probably the best thing that you can do is instead of cementing the post down in there, you put a post sleeve and then the post can be removed and capped off, then that sleeve can be capped off during the winter and things like that. So systems like that really help with that.
Yeah. And then another question, do you recommend the use of a stain blocker to help with some of the staining that can happen?
A stain blocker like before the coating, I mean, maybe if that the asphalt has those types of materials in there, it could help, but it kind of depends on what type of coating, you're using.
Yeah.
Is it compatible with that? There might be a primer kind of stain blocker thing that's compatible with a certain type of coating. It might be a good idea there, especially if you're not sure of the materials that are in your asphalt, and things like that could help. I'm not super familiar with a lot of the different I just know there's a lot of different coating systems out there.
Yeah, yeah. And then the last question here is, does MDOT have a HMA mix that is recommended for sport courts?
I wouldn't say that any of the MDOT specifications do limit the amount of shale and deleterious materials, but it's like less than 10%, I think, or something like that. So if you were just to use an MDOT, like 5EL mix for your tennis court, then maybe you would want to use, one of those stain blockers or something like that. But if you can specify like a tennis court mix or something like that, like I said, a lot of our producers here in Michigan have a specification and a mix design that they use for that. That is 100% limestone aggregate in that mix design, so that doesn't have any of the shale or the pyrite or
those staining
materials, yeah, slag, anything like that.
And then the last is just a comment that is, I think, good. Doug mentioned that asphalt should breathe for 30 days prior to color coating application. I think 30 might be even a little on the short side. At least 30 days, maybe more.
Yeah, I would say at least 30. I mean, most of the recommendations that I'm aware of are 45 days. So
yeah,
that's kind of the best practices. There may be certain manufacturers of some of the coatings that suggest 30 days or things like that. I mean, the main thing is, and it probably depends on the time of year as well. If it's a cooler, wetter time of year when you pave, it might take longer before you should actually coat it.
Yeah.
The idea is you want to kind of let the more oily. You kind of want the asphalt to oxidize a little bit and get rid of some of the finer asphalt paste that's on the top.
Which kind of goes into this last question here, which is there any type of seal coat that can be used? So you wouldn't want to use a seal coat right after you pave before you put your
Yeah,
coloring agents on, because you do want that process to happen a little bit.
yeah,
But
you want the asphalt to breathe a little bit and kind of oxidize a little bit. And so if you sealed it up, you might be trapping some moisture in there and
but
not.
in the future, after you've done that for maintenance purposes, are there seal coat products that could be used? Do you know of?
I
I
guess it
miss,
would depend on your court and your surface, and because a lot of these sport courts and tracks and things like that are colored a certain way and things like that. So they don't really want to have a whole lot of other colors or lines of things, or like
yeah,
I'm thinking of like a black seal coat over everything. I mean,
or
and I don't
even
know if you could put that down and then put another layer of the surface coating back over that. I know there can be some issues of, if you do get too many layers of the surface coatings, then that can cause issues as well, where they don't bond good together,
yeah.
and can cause cracking and different things like that.
I could see that. If anybody in the chat has any info, please put it in. This is an opportunity to learn from one another as well. But all right, I think we're caught up with questions, so you could continue on with our trails and
Sounds
paths.
good. So next up is trails and paths, and really trails and paths are similar to sport courts, except as far as the asphalt design and that, um, and in that they're not being designed for vehicular traffic and stuff. So except that they typically don't have those surface coatings applied, so that's the big difference. Um, in general, it's recommended a minimum of 3 inches of asphalt be used for bike paths and trails, where loading from vehicles will be negligible. As soil conditions deteriorate and loading increases, the pavement thickness obviously is going to be increased. With you composite sections consisting of asphalt pavement overlaying an ag base are common in Michigan. One advantage of the composite section is the ease of grading of the base course to the proper level for the placement of the asphalt pavement. It's recommended that the minimum thickness of a high quality aggregate base course be a minimum of 6 inches for an asphalt trail. Thicker base courses should be used for poorer quality subgrade materials. So typically 3/6, very similar to the sport court design. We're designing for durability. The trails are going to sit out there. They're not going to fail from loading. I do wanted to mention too, some specialty paths. I'd been involved with a couple of specialty paths here in Michigan. And one of them was a multi-use path, and we came up with this. Actually, the Snowmobile Association of Michigan came up with a snowmobile mix, and that was used so that they could, run snowmobiles with studs on it, so that it wouldn't damage the asphalt as much. So it was highly polymerized asphalt mix that could stand up to those studded tires. And then on another multi-use path, they had allowed horses on. So again, with the horseshoes and stuff, we ended up using the snowmobile mix for that as well. So specialty paths can call for specialty mixes as well. Typically with trails and paths, we're not using the tennis court mix, the 100% limestone mix, because here we're not worried about the coating and things, either damaging the coating or staining and things like that. So it is a little bit different that way. So we could use our regular MDOT mixes on here, like a 5EL mix would work great. Paths can be hard to access with conventional paving equipment, because usually we're running alongside a road or through a golf course or through the woods, or through a park or things like that. So we really have to, when we're laying out the path, plan for how are we going to pave this. You know, how can we get trucks in there? Or are we going to have to find a different way to get the mix to the paver? Um, so you want to really plan for access there. You also want to plan for the width of a paver. I mean, a good rule of thumb is if you're putting a path in, make it at least 8 feet wide, because that's kind of our normal paver width is 8 feet wide. If we get into paving a 4 foot or 6 foot wide path, that gets harder with a standard paver. You can put cutoff gates and things like that onto the paver, but it just makes it harder to pave that because the screed is, typically 8 feet wide. We also want to consider surrounding vegetation, use a weed sterilant, different things like that. Really, prior to construction, vegetation should be cleared and stumps and roots removed along the trail for a minimum of 5 feet outside the edge of the proposed pavement. This does a couple things. It allows for construction equipment access, and it also helps prevent roots and growth from eventually encroaching on the path. I'm sure we've all seen paths um, in different places where the tree roots are popping up or weeds are popping up through the asphalt and things like that. So we just want to make sure that we're properly designing and planning for that future. And also drainage is important. We want to make sure that when we're designing the path that we give the water a place to go. A lot of paths that I've seen, drainage off to the sides really wasn't, considered. And you see a lot of edge cracking along paths and things like that. That's just, if water sits along the edge of that path and can't get away, that can cause those types of issues.
We got a question about tire derived HMA, so scrap tire mixes for multi-purpose trails. Is that something that's desirable, cost effective? Is that an option for folks?
It could be. I mean, I don't know. Like, we don't have the problem here with surface coatings or anything like that. So, I mean, if you had a rubber modified asphalt that was cost effective and you could use for a path, I would think that would be allowable. Um,
All right. I think that we are caught up on our questions then.
cool. So that was pretty much it for the trails and paths. I mean, the big thing with trails and paths is kind of the layout and access. I know I've seen some paths that were paved and they couldn't, get a truck to back up to the paver. So then they're, dumping the mix from the truck into a loader, a small loader, and then taking the mix and putting it into the, driving down the path and into the paver. So a lot of those things, you have to think about. And with the access, where are your access points? It's hard to drive that loader back and forth, a half a mile down a path, and to keep the mix hot and keep the paver fed so that it can actually move and pave the asphalt. um, so all right, next we're going to talk about porous asphalt. So porous asphalt is a specialty designed mix that allows water to drain through it. So basically, it's an asphalt mix that's designed with typically 16 to 22% air voids instead of our typical 4% or regress to 3% air voids. So this shows kind of a cross section of a porous pavement. Keys are an uncompacted subgrade. And then we have clean, large size crushed stone with high voids above that. And that's kind of a reservoir course. So the idea with a porous pavement is, we're going to drain that water through the asphalt down into this reservoir course, and it's going to be stored there until it percolates down into the subgrade. That's why the subgrade's uncompacted. So then we typically have what we call a choker course, and that's a clean 1/2 inch crushed aggregate. And that's really just to kind of cover up the larger stone reservoir course so that we have a stable platform to pave on. And then the porous asphalt is placed at 2.5 to 4 inches thick, all in one pass. And so that's how a porous pavement section is built. This next slide shows an animation that shows, kind of how the porous pavement works. As it rains, you can see the water building up in the reservoir course. and then it slowly percolates down into the subgrade soil. So that's how the porous pavement section works. So eventually all that water will drain out of that subgrade soil until the next rain event. So where have we seen porous applications? Really parking lots. A lot of when they started doing them here in Michigan, that's kind of where things got started, were parking lots. There's also been quite a few roads that have been paved in porous. And then recreational facilities, paths, tennis courts, things like that. I was involved in a project. This is actually a picture of it here on this slide. It's at Washtenaw Community College, and over by Ypsilanti, and they wanted to do a porous basketball court. Basically, they didn't want to, have a tilt to the basketball court. They wanted to build it level and be able to drain the water down through the basketball court without having any big puddles or anything like that. So this was built back in 2007. So it was kind of interesting because they also wanted the mix to not be so coarse, because a typical porous pavement is pretty open looking and coarse looking, so that if people fell on the court while they're playing basketball, they didn't want to get them all skinned up. So we found a spec over in Pennsylvania that it was a finer graded porous asphalt mix, and so that was the spec that they used for putting this basketball court in. So like I said, a typical porous pavement, you can see from the inset picture there, a picture of a quarter and the open look to the actual porous pavement itself. So successful use of porous pavements make it necessary that certain site criteria is met. First, we want to make sure that the soils will allow water to infiltrate. So we're typically putting in porous pavement systems in lieu of like a retention pond. So it's really part of the stormwater management system. So in order to do that, we want to make sure that, our subgrade can allow that water to infiltrate. EPA recommends a 1/2 inch per hour. 1/10 of an inch per hour is still okay. You just have to take that into account in your hydrology measurements to make sure that the water will drain quick enough for you. Typically, depth of bedrock is greater than 2 feet, depth of high water greater than 3 feet. Not recommended to put in on fill. And here in Michigan, especially with frost depth, we want to make sure that that pavement section exceeds the frost depth. So we can do a soils investigation, typical to the investigation we do to put in a drain field at a house. Test the permeability, and determine that depth to high water table and depth to bedrock. Some keys to success for the design. We want to limit our surface slopes to 5%. If the slope of where we're putting in a porous asphalt, like if it's a parking lot or whatever, if it's steeper than that, we want to maybe terrace the parking lot. And then put conventional asphalt in the steeper sections to get between the different layers of parking lots. We want to avoid piping water long distances, so you want to look for and spread that infiltration over the largest area possible. 5-to-1 is a rule of thumb, impervious to infiltration area. So a lot of that comes down to, looking at all the water that you're collecting into this porous system and where it's going to go and how long it's going to take to get it out of there.
When we're talking about the design check, is there, with the uncompacted subgrade, is there a concern of settlement or early distress with that? Is there a limitation on how heavy a load or how heavy of traffic you can put on this kind of a pavement?
There's not a concern with any settlement or that, mainly because your reservoir course, the large stone, it's 1 to 3 inch large stone. It's typically 2 to 3 feet deep, depending on how much water you've got to fill in there and stuff. So they're typically pretty stout pavement sections. Haven't seen any of that happening. I know some people have done some research and when we were doing the roads and the road designs and how much traffic it could hold up to and things like that. And we really were able to design a slightly less um, or lower air void mix that could hold up to higher traffic. So they actually went through City of Ann Arbor when they were designing their roads. They actually did a super paved mix design on it at a lower air void, and compacted it and actually measured density. Typically, with parking lots and paths and things like that, you're not measuring the density on it because you want that openness to get the water out.
Yeah.
But
All right.
haven't seen a lot of problems with that because typically we're not putting these out on the freeway where you got a lot of truck traffic and things like that.
All right. We got another couple of questions that are about maintenance, which I know you're going to answer in just a second. And then another one that was about binder percentage, which you're also going to answer in just a second. So I do see those in the chat, guys. Chuck's going to get to them in just a second.
Not a problem. So material selection, we've got specifications. I'm going to kind of skip through some of this stuff because we're not getting into the whole mix design stuff. It's more about how they're different. So, but there are, certain things that it has to meet. So we do have a guide specification here at APAM, and that's listed on our website. So that has been used around the state here on a lot of the installations. And like I said, we came up with a special one for the basketball court. So keys to success, here it is. The binder content is typically 5 to 6.5%. Air voids greater than 18%. Drain down less than 0.3%. You want to evaluate for moisture susceptibility. A mixed design is required. So construction, we want to make sure that we're building the porous pavement last. We want to protect it from any construction debris because obviously we'd hate to pave this porous asphalt, have other construction activities on the site going on, and a bunch of dirt drains down into it and plugs it up. So we don't want to do that. We also don't want to drive heavy equipment over it and all that. So this is kind of talking about in construction. We want to, cut down to the subgrade, prepare that, place the reservoir course, place our choker course, and then place the porous asphalt. After we do that, we want to restrict traffic to it for at least 24 hours. Again, protect that porous pavement from contamination and check the permeability. We want to make sure that the water is draining through it properly. Post-construction, we want to inspect for design compliance during storm events. Most of these installations, the first time it rains, there's a bunch of us out there looking at it, making sure everything's working good. Want to make sure that the vegetation is established before removing any temporary stormwater measures. Again, we don't want to, clog up our new porous system here. Do not sand for snow or ice. We don't want to use regular road salt as well. Some liquid de-icing compounds may be used. What we found is with the porous pavement sections is typically we don't get a lot of ice or snow buildup. Obviously, when it snows really hard and really fast, snow can build up onto it. So kind of the best practice is if you're plowing that, you want to keep your blade up on the porous so that you're not scarring it or scuffing it or anything like that. But we find that any small buildup of ice or snow really melts really fast. And mainly because the water can't just puddle on top of the surface there. As soon as it starts to melt, it goes right down into the porous system. So another important thing is make sure that we sign for maintenance. Having an educational sign we found to be a good thing, and a lot of the parking lots have these. And we want to make sure that people understand that this is a different things. So we want to make sure that the maintenance people are aware of how they need to maintain it. So you want to inspect several times first few months during storm events, inspect annually after that. The pavement surface may be flushed or vacuumed. Most people have found that, running a street sweeper and backing it out once or twice a year seems to be working pretty good. And any damaged pavement can be repaired with regular hot mix, as long as you're not covering, basically you're not closing off more than 10% of that infiltration area. Maintenance is important, like I said, not salting or sanding for snow. One of the roads that the city of Ann Arbor built, their maintenance crews accidentally sanded the pavement after it was open to traffic the first winter, and it plugged it up. So it's no longer a porous pavement section, but they do have another one in town that's been in place for almost 15 years now. So it's working great. So any other questions on porous that I didn't cover there, Ingrid?
No, we have caught up.
All right. Other kind of specialty mixes. I just wanted to touch on a few of them here. We have a mix that we call Asphalt. It's an asphalt stabilized crack relief layer. There is a specification for it. MDOT uses it over concrete pavements to reduce reflective cracking. Typically, we're using the PG 64 -28 binder with a 0.5% liquid anistrip additive. Asphalt content is 3 to 4%. So it's a low, it's really kind of like a low asphalt content porous mix. And the idea is that as that fracture energy is coming up from a joint or a crack below, it's going to dissipate that rather than letting it go straight up. So constructed, placed in a single layer, typically 2.5 to 4 inches thick. We're just compacting it with a steel wheel roller. We're not trying to get density on it. We just basically want to seat it similar to like what we do with the porous asphalt. So, and it has been working very well. MDOT uses this on a lot of different roads. Another mix that is different is SMA, or stone matrix asphalt. Really, SMA consists of two parts. It's a coarse aggregate gradation and a binder rich mortar. So how are they different? The gradation, the asphalt content, dust content is all different in a stone matrix asphalt. So you can tell here on the one side is the aggregate skeleton for a dense graded mix versus the stone matrix. You can see with the stone matrix, the key is stone on stone contact. So the gradation is different. We have more larger size particles and then smaller size. We kind of gap out the whole middle section of the typical aggregate gradation. Hence, MDOT used to call it gap graded super pave, but now they call it stone matrix asphalt like everyone else in the country. Asphalt contents are typically higher than the regular super pave mixes. Again, it's to get that rich mastic in between the stone on stone contact. You also have a higher dust content to soak up more of that liquid asphalt for the mastic in between. And then we're typically adding polymers, mineral fillers, and fibers, hydrated lime, liquid anistrip. That's all part of that mastic that really makes this a tough mix. It's very rut resistant. We have that stone on stone contact for load distribution, some surface texture, water drainage. It's kind of an open looking mix, so we see less spray from cars behind the cars when it's raining out and things like that. It's very durable, very long lasting. MDOT uses it on a lot of composite pavements when they're doing overlays. They see less reflective cracking, is less severe when it comes up through there, and it's been working for many, many years. Another specialty mix are fuel-resistant asphalt mixtures. These are used mainly at airports. And the FAA, the Federal Aviation Administration, they have a spec. It's the P404 fuel-resistant spec. Benefit, it's a highly polymer modified mix. It has outstanding rut resistance, resistant to fuel and oil damage, eliminates the need for sealers. Mix design has increased asphalt content, which provides improved fatigue and increased pavement life. This combination provides resistance to all potential pavement distresses, results in longer pavement life and lower life cycle costs, is what they've been finding at these airport installations. But it's not really just for airside anymore. Some people are starting to use these for bus lanes, heavy channelized, slow moving traffic, where you might have oil and fuel leaks, areas where rutting may be an issue. So it's not just for airports.
So I'm going to butt in just for a moment here. We're at the top of the hour. I did put the SurveyMonkey link into the chat. Let me do that right now again, just so that it's at the bottom of the chat. I do have a couple of questions about some of these other types of pavements. One question was just, do you know the Ann Arbor porous pavement, the 15-year-old porous pavement, is that the oldest that you know of in Michigan, or do you know of anything
for a road? For
okay.
a road, I think it is, yes. But
okay.
the oldest porous pavement is at the I forget the name of it's at a Ford plant where they park the Mustangs, the Ford Rouge plant. That was in 2000.
Okay.
And that was an interesting one because the soil conditions were bad there. So they designed it as a porous pavement, but then they had to collect it in the reservoir course and outlet it into a swale. So they had a vegetated swale that was actually like cleaning the water before it got outletted.
Gotcha. All right.
This was an interesting design.
Yeah. Another question is about the soil matrix asphalt. Is there a downside to using it? Because this person said it seems like it's great. So is there a reason not to use it?
The SMA?
Yes.
It's expensive.
Okay. There's always a downside.
It's very expensive. But yeah, the performance has been great. So it's typically used on higher volume freeways is where we used it most here in Michigan. Some people are starting to use it in some lower volume applications, but it is typically a lot more expensive than the regular mixes. Although we have changed the specifications with MDOT a little bit, and our hope is to kind of reduce some of those costs and hopefully see it used more because we think it's a great mix. The performance we've seen has been great. I've got a few more slides. I don't know if anyone can stay on
I think let's keep going. If you have to drop off, we will have this we are recording this. So you can catch up on the last if you do have to drop off. That survey again is in the chat right now. So we'll keep going for those of you who can stay. Otherwise, we'll have the recording. You can catch up on the last little bit here later. I do have one last question here.
I was going to say, if there's more questions, let's get to those first.
Yes, I do have one more question, which was, what is the crack release mix called?
The ASCRL, ASCRL. So asphalt stabilized crack relief layer.
Perfect.
Yep.
All right, that was our last question. So
I think there's a copy of the spec in the slides there. Perfect. The first page of the spec. It's a MDOT frequently used or previously used special provision.
Perfect. All right, I think that gets us caught up, and we can wrap up the last of these slides.
Yeah. Thanks, Ingrid. Yeah, so I wanted to talk a little bit about perpetual pavements next. It's not really a different type of a mix. It's more of a different design concept. So really constructing long-lasting pavements consisting of thick asphalt layers overlaying a sound foundation has been the goal of pavement engineers and contractors for a long time. Full depth pavements are those placed over prepared subgrade, and these have worked well when the soil is not subject to volume change or settlement. The fact that these strategies are all successful becomes evident when considering how often rehabilitation technique of mill and fill is used. So in other words, it's perpetual pavements aren't a new concept. It's full depth asphalt, deep strength, just milling and filling is your maintenance. It's not just for freeways. So we long have seen a lot of older pavements before we came up with this perpetual pavement design concept that were acting like perpetual pavements. So we started studying those and trying to quantify how we could design them so that we could design them to be perpetual. So really, this is kind of the concept underlying perpetual pavement. So we've got our pavement foundation or our subgrade, our base material, all that, and then we have our asphalt layers. So the black, purple, and black here are our asphalt layers. And basically, we want to look at the maximum tensile strain at the bottom of the asphalt so that as it's loaded, it doesn't reach a point where it starts cracking from the bottom up. We want to force it to crack from the top down so that then periodically milling and resurfacing that top layer, the bottom layers will last indefinitely. And that's the concept of perpetual pavements. So we want to avoid any kind of repeated bending at the bottom of the asphalt because that's going to cause bottom up cracking. And we want to eliminate repeated deformation in the base layers because that leads to rutting. So I'm going to kind of go quickly through all these. We're not going to be teaching people how to design things. I could spend an hour just on the whole how to design a perpetual pavement. But basically, it's making sure that we have that so that we're not getting the rutting and not getting the cracking. So they've done a lot of studies, and we want to limit the bottom of the asphalt bending stresses there less than 65 microstrains and limit the vertical compression at the base to under 200 microstrains. And if we do that, we should not see bottom up cracking or any rutting, structural rutting. So I do that all to say that it's great that, we used to design pavements that seem to act like perpetual pavements, and now we're actually designing them to be perpetual pavements. So the APA, which is the Asphalt Pavement Alliance, has an annual perpetual pavement award. And the award criteria, they have 3 different categories. The first one is by performance. So to be eligible for by performance, the pavement has to be over 35 years old, no more than 4 inches of structure added to its life, and average interval of resurfacing of greater than 13 years. By design, I think my slide's messed up here, I guess. By design doesn't have to be 35 years old, or by conversion, those don't have to be 35 years old. Those are just recognizing projects that have been designed as perpetual pavements, either as a straight reconstruct or by conversion. So those are pavements that were in place and they did a major rehab to them and designed them as a perpetual pavement. So here in Michigan, by performance, we have 3 past winners. The 2007 award winner was for M24 in Tuscola County from Mayville to M46. That was originally built in 1956. And so it's still going strong after all these years. The 2009 award winner, US 31 in Ottawa and Muskegon counties from 3rd to Heil Road. That one was, over 60 years old when that one was built, when that one won its award, and it's still in operation today. And the 2015 award winner, M20 in Isabella County from Isabella-Mecosta County line to Wynn Road. Now, this year, there was just announced that the Michigan Department of Transportation won their first by design award, and the 2024 award winner is I-96 westbound in Wayne County from Schaefer to M39. This was one of the initial perpetual pavement designs that MDOT did. And after 19 years, so just last year, they did their first mill and fill on that road there. And that one was actually the top course on that perpetual pavement was an SMA mixture. So we think that's why it lasted, 19 years before they had to do that. And then by performance, or by conversion, actually, another error on my slide. Sorry about that. By conversion, 2004 award winner was Samaria Road. Monroe County Road Commission won that. Samaria Road between US 23 and Telegraph. On that project, they removed the old concrete, placed some recycled asphalt pavement down, and then did a full depth reclamation of that wrap with the existing ag base, and then paved over that, and designed that as a perpetual pavement and won that award. So in summary, perpetual pavements, the structure can last 50 plus years. We want to make sure that, the bottom up cracking doesn't happen and that we don't get any subgrade deformations there that can lead to rutting. So really basically forcing it to crack from the top down and do periodic milling and filling, and the rest of the pavement structure can remain there indefinitely. So with that, I kind of went through that pretty quickly, but if any of you are still on and had any questions on perpetual pavements, I can stay on here for a few more minutes and answer any other questions, but thank you.
Yes, thank you, Chuck. I don't think we have any other questions. There was a question about whether the perpetual pavement award, is that a nationwide award or is that Michigan?
It's a nationwide. Yep. The Asphalt Pavement Alliance is a national consortium of the National Asphalt Pavement Association, the SAPAs, which are the State Asphalt Pavement Associations, and the Asphalt Institute.
Awesome.
Yeah.
We got a question about initial costs. What are the initial costs associated with the perpetual pavement, I guess, compared to traditional pavement?
Yeah. I know that like when MDOT did that I-96 job, they did a cost comparison, and I think it was between around 15% more expensive, I think, the initial cost on it.
Okay.
They figure with the extension of their life cycle costs, it was well worth it. I think they showed that it was actually, well, that was with their projections. They
Yeah.
update that now because I think it lasted longer before they did the first maintenance on it too. So well, I'm sure we're going to see a lot bigger cost savings on those.
Yes, I have doubts that things are going to start getting cheaper for anybody, anywhere, anytime soon.
Yes.
That does not seem to be the trend for the last several years, for sure.
No.
Is there data anywhere else available about perpetual pavement? From I guess I'm not 100% sure the question. If maybe other projects or other data available about that design life.
Oh yeah, there are a lot of. I mean, there's quite a few perpetual pavements that have been designed that way here in Michigan. I know MDOT has done 3 or 4 of them. Monroe County did that one. I know City of Ann Arbor did a local road perpetual pavement design probably 10 or so years ago.
Oh, the question, we got a clarification here. Is there life cycle comparison data available? Do you know? Does MDOT have that published somewhere?
They do not have that yet. No.
Okay.
Yeah, their oldest ones are only like, because I think the first one was done the year before on Telegraph Road. And I think that one's like 20 years old now.
Okay.
But they don't have all that data because they're going to need some more than probably one site. The way they do their life cycle cost analysis, they probably need a couple of more maintenance cycle.
Okay.
But we could probably do a projected one and see that. But for what MDOT does right now with their life cycle analysis, they wouldn't have that data.
Okay. So stay tuned, I guess.
I guess that's the way to say it.
Yeah. So I did put that SurveyMonkey link in the chat. If there's other topics that you would like Chuck or other asphalt experts to talk about, let me know, because we will bring those folks in, and we can do other topics as well. If you want a whole session just about perpetual pavement, we're happy to do that. I guess I'm speaking for Chuck. Chuck, are you happy to do that?
I rushed through like 10 slides there.
Yeah.
I think the regular perpetual pavement thing has,
Yeah, we could definitely make that happen for you guys.
Last an hour at least.
So let us know if there's other topics that you would like to hear about, and we will do our best to make that happen at later in the year here. Also, if you're submitting that SurveyMonkey link, if you have any trouble, let me know. I'm going to stay on the line a little bit. If you have submitted it, you're free to go. Thank you for staying for all of this time. I'm going to stop the recording now.